This is the last video of the year for geometry. It is for lesson 98. It is due next Tuesday the 19th, and it is law of cosines, which you'll see law of cosines this year. You're going to see it next year in Algebra 2. You'll even see it in pre-calculus. You'll see it in your college math classes that you take. So that's why I wanted to cover law of cosines. We've already covered law of sines. Now I want to cover law of cosines. And like I said on the test on Friday, there's lots of law of cosines. So this will be a good help for you on the review if you need it. But again, this is the last video. This is the last assignment. I don't have anything due next Thursday, the 21st. That's the last day of school. So this needs to be on Tuesday, on the 19th, because I'm not even going to check my email on Thursday, because you can get it in on Tuesday. So make sure you get it in so that you get all the grades you need and that kind of stuff. Okay, so law of cosines, which I've already talked about. I do it a little differently than the book because I kind of skipped some steps, which I would think y'all would just love that. So in a triangle, law of cosines is more of a pattern than a formula. Like there won't be a formula that you write. But just remember that when you set up a triangle, whenever you set up a triangle, which you're going to do this a lot more in Algebra 2 and pre-calculus than we have in this one, when you're using law of sines and law of cosines, you always put angle A across from side A. You always put angle B across from side B. You always put angle C across from side C. Okay? So that if I want to find side C, then I better have angle C. And I look for the sides around the angle. So I don't have C, but I don't have side C, but I better have angle C, and I better have side A and B, or I can't do this. So it's going to be the square root, because like I said, I've skipped some steps. So if you look in the book, you're going to see a C squared and then all this stuff. Well, I just skipped the step, and because we've got to take the square root anyway, of A squared plus B squared minus 2AB cosine C. Okay? So the side I'm looking for, and here's the angle I've got. And these are the two sides I've got. So if I wanted B, it'd be the square root of A squared plus C squared minus 2AC cosine B. Notice, side I'm looking for, angle I've got, angle opposite. Then if I want side C, it's B squared plus, not C, A. It's B squared plus C squared minus 2BC cosine A. Okay? So that's the pattern. The side you're looking for, the angle across from it. The side you're looking for, angle across from it. Side you're looking for, angle across from it. Okay? That's the way you find the side length. So let me show you that, and then we'll talk about angles, which I'm going to switch markers because that one's running and it's bugging me. Okay, so triangle. Triangle. This is angle T, U, V. This is 80, 22, and 60. And we want C, so they've put a C on there. It should really be a V if we're technical, but they didn't. That should be a V, but they put a C on it, but we want C. So what it is we take the square root of the two sides we've got, 80 squared plus 60 squared, minus 2 times 80 times 60 cosine 22, because that 22 angle is across from C, the angle we want. Then you just type it in your calculator, okay? So second square root, then put in 80 squared plus 60 squared minus 2 times 80 times 60 cosine 22. And you get about 33.15. Round it to whatever you're asked to round to, 10th, 100th, that's to the nearest 100th, but round to whatever you're asked to round to. So that's finding a side length. Let's do another one where we're finding a side length, and then we'll move to finding the angles. So here, this is E, and then that's 23. This is 11. This is 20. It's angle F. So this is side F because it's across from angle F. And this is D. Okay. So we want to find side F because that's all I can find. with this. I've got the angle across from it and the two sides around it. So F is going to be the square root of my two sides, 11 squared plus 23 squared, minus 2 times 11 times 23, cosine 20. Because 20 is across from F. The angle 20 is across from side F, so that's why I put the 20 in there. And it's the only angle we've got. So again, type it in the calculator just like it is. So 11 squared, square root it, 11 squared plus 23 squared, minus 2 times 11 times 23, cosine 20. So it's about 13.2 if we round to the nearest tenth. 13.2. Again, round to what you're asked to, except for on the angles. On the angles, I want it to the nearest whole number. So if they ask you to round to something else, don't do that. Okay, so now let me show you how you find angle measures. So let me set up just a general triangle again. So here's A, B, and C. So here's side A, side B, side C. So then if I want angle A, I'm going to take side B and square it, side C and square it, subtract side A because I'm looking for angle A. And then I'm going to divide by 2 times B times C. So what's happened is it's taken the original law of sines and solved for an angle. So I've already done, like I'm giving you a shortcut and I want to see you use this. I don't want you to use what the book shows you to do. It's too complicated, it takes too long, and we don't have to do it. Except for I forgot the extremely important thing that we have to put in front of it. It's got to be the inverse cosine because we're looking for the angle measure. So angle A would be the inverse cosine of all this stuff. Again, it's more of a pattern than a formula, so I want to show it all the patterns. If I want angle B, it would be the inverse cosine of side A, side C, minus side B, because I'm looking for angle B, over 2 times A times C. It's a pattern. If I want angle C, it would be inverse cosine of side A, side B, minus side C over 2 times A times B. Okay, so what happens when you're finding an angle measure on these is you're just given side lengths. Like you're given side 30, this is side 32, this is 62, and this is 57. So you're given these side lengths and you're asked to find one of the angles. So here's C. We're probably going to find all of the angles because I want to give you practice on doing law of cosines. So we're going to find all of the angles, not using law of cosines on all of them, but on 2 of them we're going to use law of cosines. So there's my triangle. So I want to find angle C. So angle C would be the inverse cosine of, now 62 is across from C, so I want to use these two sides first. So 57 squared plus 32 squared minus 62 squared all over 2 times 57 times 32. Close it up. Okay, now here's where you got to be careful. You got to be very, very careful putting this on your calculator. You've got to do some extra parentheses around the numerator and the denominator, okay? So you're going to do second cosine, start a new set of parentheses. Put in the numerator 57 squared plus 32 squared minus 62 squared, close parentheses, divided by open parentheses, 2 times 57 times 32, close, close. And then you get 83. So angle C is about 83 because I want them rounded to the nearest whole number. Do you hear that? I want them rounded to the nearest whole number. I do not want you, if I think the book sometimes says nearest tenth, I don't want that. I want them rounded to the nearest whole number, so make sure you do what I ask you to do. Okay, so that's C. Now let's do angle D using law of cosine. So inverse cosine, angle D. So side 57 is across from angle D, so I'm going to use these two sides first. So 62 squared plus 32 squared minus 57 squared all over 2 times 62 times 32. Because 57 was across from D, so it's the one that gets subtracted. So again, grab my calculator, plug it in very carefully. So second cosine, because I've got to do the inverse cosine, open a set of parentheses, 62 squared plus 32 squared minus 57 squared, close parentheses, divided parentheses 2 times 62 times 32, close, close. And you get about 66. So D is about 66. So if we wanted E, we would just do 180 minus 83 minus 66 to get that, and this would be 31. Don't ever use law of cosines on all three angles because sometimes it'll throw you off. And you want to make sure they add up to 180. So you can do two angles, law of cosines, and then the third angle, always subtract for. Always subtract for the third angle, no matter what you're using. Whether it's law of sines, law of cosines, whatever. Always subtract for that third angle. Okay, so let's do this again. Let's see. This is y. This is 10, 8, 3, x, and z. Okay, so there's my triangle. And I'm going to find all the angles again. So I'm going to start with x. There's x. So if I want angle x, I would do inverse cosine. Again, 8 is across from x, so I use the two sides around it. 3 squared plus 10 squared minus 8 squared over 2 times 3 times 10. And then I type it in the calculator. So second cosine, open a set of parentheses, 3 squared plus 10 squared minus 8 squared, close parentheses divided by open parentheses, 2 times 3 times 10, close, close. And you get about 41. So x is about 41 degrees. Now let's find y up at the top. So it's inverse cosine. This is y. 10 is across from it, so I use the 2 around it. So 3 squared plus 8 squared minus 10 squared over 2 times 3 times 8, close parentheses. So then we do second cosine, parentheses, 3 squared plus 8 squared minus 10 squared, close parentheses divided by open parentheses, 2 times 3 times 8, close parentheses twice, so 124. So this is 124. So if I want z, I just do 180 minus 41 minus 124 and get 15. So this angle's 15. So that's how you find angle measures using law of cosines. I've shown you side lengths, I've shown you angle measures. Okay. Then you have examples where, let's see, we've got building 1 here, building 2 here. Building 2 is really big. And they've actually got a triangle drawn from building 1 to building 2, like this. You're given that this is a 99-degree angle, that this is 320 feet, and this is 580 feet. And we want the height of B. So again, x equals square root of 580 squared plus 320 squared minus 2 times 580 times 320 cosine 99. Whoops, I don't need parentheses. So we want the side opposite the angle. That's why we put the cosine 99. Type that in your calculator. So we would just put second square root 580 squared plus 320 squared minus 2 times 580 times 320 cosine 99. We get about 705 feet if we round it to the nearest whole number. Okay, so that is law of cosines. That is law of cosines. So let me go over your assignment for this lesson for 98. Again, it is due Tuesday the 19th. It's due next Tuesday the 19th. So on 98, you're going to do the warm-up on page 636. You're going to do the practice A through D. Then on the lesson, you're doing 2 through 6, 9, 11, 14, 17, 21, 22, 24. Not many. It's not many at all. 2 through 6, 9, 11, 14, 17, 21, 22, and 24. I'm going to go through, just like I've always done on these videos, talk about some of the problems. One that I'm going to start with is warm up number 2, where it says decompose this vector into its horizontal and vertical components. So remember, your horizontal component is your magnitude times the cosine of the angle. And then your vertical component is the magnitude times the sine of the angle. So you've got your magnitude right there, and then your angle's 36, okay? Then on number 3, it looks like you need to do inverse cosine. On the warm-up on number 3, you've got adjacent and hypotenuse, so that's inverse cosine because you need to find the angle measure. So like on number 3, you're going to do an inverse cosine with some numbers in it to find the angle measure. And round it to the nearest degree. That's what you're asked to do. Okay, then on D, on the practice, I want to set up this triangle for you. Oh, first of all, on C, use Pythagorean theorem. Use a squared plus b squared equals c squared. I know they tell you not to, but that is a right triangle. And if you've got a right triangle and you're looking for C, you use Pythagorean theorem. So don't use law of cosines like it asks for. Use Pythagorean theorem. Use a squared plus b squared equals c squared. Then on D, we have Strom and Milan are walking away from each other at a 66-degree angle. So that means we've got a 66-degree angle here, okay, because they're walking away from each other. If they stop when Strom is 45 yards from the starting point, so Strom is 45 yards. Let's see, and Milan is 38 yards. This is Milan. How far is Strom from Milan? So you want that distance right there. Perfect law of cosines. But that's how that triangle sets up. So you need to draw the triangle and work it out. So then let's see, 2 is a circle thing. Oh, on 3, some of you are getting your annulus is wrong because you're looking at the circles wrong. So on 3, the big radius is 50. Don't subtract anything from it. Don't add anything to it. The small radius is 45. So use those two numbers in your area equals pi r squared to subtract, okay? The big radius is 50. The small radius is 45. So be careful with that one. 2 chords are congruent, and one is 3 inches from the center of the circle, then the other one is 3 inches from the center of the circle because they're congruent chords. So like on number 4, you've got congruent chords. This chord is congruent to this chord. Well, if this chord is 3 inches from the center of the circle, so is this one. That's number 4, so you need to draw it, finish labeling it. Remember number 5, you want magnitude, so that's just the square root of x squared plus y squared. That's how you find the magnitude on number 5. Then on number 6, it says that TU is the mid-segment. You want to find the value of x and y. So y, just cut 112 in half is all you have to do. And if it's the mid-segment, that means x is the same as 58. That means x and 58 are the same because it's a mid-segment, because T is a midpoint. So RT and TQ have to be equal. So x would have to be 58. But you need to draw that and label that stuff on there. Then on number 9, let's see. In a regular square pyramid, it has a height of 100 feet with a base of 200. There's a second floor located halfway at the pyramid. What is the area of the floor? So here's the side of the pyramid. This is 200. This floor is halfway up. Guys, it's a mid-segment. So these are the midpoints. So that means I cut 200 in half. Just like number 6. You're going to cut the 112 in half for y. We're cutting the 200 in half here. It's a square, so you want the area of that floor. So you want the area of a square that has a side length 100 is what you're doing on number 9. Then number 11, you're doing law of cosines. Law of cosines is number 11, so follow the notes. Number 14 is you're just moving left 7, so that's just going to affect the -1. Be careful with that one. Number 17, write the equations. You've got concentric circles. They give the center. Just be careful when you count because your scale is kind of messed up. So be careful when you count for your radius on number 17. Like the radius of the small one is 5. So be careful with the radius of the big one. Then 21, you want the exact length of the leg of an isosceles triangle with a hypotenuse of 75 inches, exact length. So an hypotenuse, it's an isosceles right triangle. So you have a 45, 45, 90-degree triangle where your hypotenuse is 75, and you want exact, so no decimals. No decimals on number 21. No decimals on 21. 22 is law of cosines. You're using law of cosines on 22. And then on 24, you're going to set up an equation like, see that 87 is hard to tell. That 87 is real hard to tell where it is. But actually that 87 should be right there at the angle at H. Otherwise you can't work this. So it's 2x plus 6 and it's 76. So you take 2x plus 6 plus 76 divided by 2 equals 87. Because you got to take the two arcs, add them, and divide by 2. And that 87 is real hard to tell where it is because I kind of put it right here in the middle of the side, and it's not. It should be the angle measure at H. So that's the way you set up 24. And that's it. Again, last video, last assignment, due next Tuesday on the 19th. Do a good job on it. Make sure you do a good job on your test and your review. Have a great summer. Hopefully I'll be able to see some of you in Honors Algebra 2 next year, if you want to take Honors Algebra 2. But anyway, hopefully next year I'll see you anyway, like that we'll see each other and not do this video thing anymore. But have a great summer. Have a safe, healthy summer, and I'll see you next year.